Let's solve this equation, which is quadratic in cosine theta. Before we dive into it, let's think about what we would do with 2x squared equal to x plus 1. So this form is essentially the same as this. It's just instead of cosines here, we have x's. Well, any quadratic equation, life is good when we have all our terms on one side and 0 on the other, because then we can factor or use the quadratic formula. If we factor this, we'd use a 2x and an x out front to get to 2x squared. And now I need to come up with two numbers that multiply together to get a negative 1. And then when I distribute, I end up with a negative x. Turns out that a plus 1 and a negative 1 will work here. Notice these two terms multiply to be negative 1. And then negative 2x plus 1x gives me a negative 1x. So now we have two expressions multiplied equal to 0. So we set each equal to 0 and solve for x. We're going to follow the same exact pattern working with this problem. So get all of our terms on one side and 0 on the other, and then factor. Instead of 2x and x, I will use 2 cosine theta and cosine theta, and plus 1 minus 1. Set each piece equal to 0 and solve. Solving this equation, 2 cosine theta is negative 1, so cosine theta is negative 1/2. So what angles theta in between, or greater than or equal to 0, strictly less than 2 pi, will give me a cosine value of negative 1/2. That's going to be 2 pi over 3 and 4 pi over 3. What about this other equation? Cosine theta equal to 1. Well, if I'm only allowed rotation starting at 0 and getting up to 2 pi, but not equal to 2 pi, theta would have to be 0. So this equation has three solutions: 2 pi over 3, 4 pi over 3, and 0. Again, given the restriction that we started with.